So welcome all. This video is for your experiment 8B, and in this presentation I have tried to guide you how to write the necessary script for completion of the experiment 8B. Let's start. First of all, for this experiment 8B, we'll be using different differential equation solver, and it is termed as ODE solver in MATLAB. Generally, ODE 45 and ODE 15S are used. If you ask my experience so far, I have used ODE 45 and ODE 15S only. It is said, in any case, ODE 45 fails, please try with the ODE 15S. Now, this differential equation solver basically solves the differential equation and based on Runge-Kutta method. So moving to the next slide. First of all, if I have a ODE solver, you can see there is a general syntax for this solver. It says t comma y. This is the solver. I have a function tspan and y0. Let's see what does it mean. So this f string contains the name of the function describing the differential equation. We will see in the corresponding .m file where we are going to write those things. Tspan means that I have an initial value, I have a final value of the time, so that solver should integrate from t0 to t final. And y0 means initial conditions for the differential equation. So this is the general syntax. Now moving to the next slide. Here I have shown you, if I type help ODE 45, what should be the MATLAB command syntax for that. So once I type this help ODE 45 in MATLAB command window, I can see the very similar thing what I have discussed in the previous slide. It is T out, Y out, ODE 45, the function related to the differential equation, tspan and y0, and everything remains as it is, and it says this y dash equal to fty, it is going to solve. Next, I have typed for input command syntax. So if I write help input, it will be prompting for user input, and the syntax says that this is the result or output I will get if the input, the prompt, the displays the prompt string on the screen, waits for input from the keyboard, evaluates any expression in the input and returns the value in result. That means, so if I write input prompt or input some line, it will ask me that please give the input. If I provide the data will be stored in the result. We will see shortly in the program. So this is our assignment number 1. The question is, write a MATLAB script. Script means .m file to draw the phase trajectory or phase portrait described by the differential equation, and all the various initial point has been mentioned. It has been also asked that comment on stability. For this assignment, what we will do, first we will try to write a function which will describe this differential equation. That means how I am going to read that. x1 dot equal to x2 and x2 dot equal to minus x1 and minus x2. I will store this file. Then I will use the ODE45 to solve this differential equation. Now, this is a program or a subroutine written in the MATLAB environment, and as you have seen, so x1 dot equal to x2, x2 dot equal to minus x1 minus x2. So it is a subroutine we have written. Please do remember, if I am using function command in the MATLAB, so this string, whatever name we assign here, the same name should be used for this .m file. So if I write abcd here, if I save as this .m file, it should be abcd.m. It says that if I give the input t and x, then from this x dot 1 is the x2 and x dot 2 is minus x1 minus x2. Moving to the next slide. So here is the main script for the assignment 1. Suddenly I noticed that I have written assignment 2 there. So I have paused the video, done the necessary correction and came back again. So it is basically assignment 1 8b. Now it says that how many initial points I require, and for that initial number of initial points, it is going to ask me that enter the initial value of x, enter the initial value of y. So once I provide that value, I have decided what should be the t-span where this ODE45 is going to integrate or going to solve. So this is our initial value. So keeping in mind the syntax of ODE45, we have written third bracket t comma x ODE45. So if you remember, the function was defined or the corresponding differential equation was saved in phaseplot.m. So inside a inverted single inverted comma, the phase plot, I require this t-span, that is what should be the length of this time where the differential equation will be solved, and with the corresponding initial input. Now if I use this plot command, you can see that obviously after the solution from this x, the all row first column, all row second column is going to plot, but you can see there is one more interesting thing, that x11 comma x12 with a star. Can you guess or what you are expecting from this plot command and with this star? Please think on that. And I have used grid on hold on because for one set of initial input it will plot. I wanted that graph also. Then again moving back to the giving the input for the second set of initial values, plotting the graph, and so on. Now in the MATLAB environment, you can see whatever I have discussed. I have written that. I have defined a function. So you can see if I write a function, that should be ended with the end command. Written the function, saved it, the whatever name I have given, saved it with the same name. Then I have written the code whatever we have discussed. Now I wanted to execute this and wanted to show you what will happen if I execute this script. So let's start. So if I give run, it is asking how many initial points you have. If you remember, for this assignment 1, the question has been asked for 4 set of initial points. So for the 4th set of initial point, I am giving 4. So that means the loop will run for 4 times. So enter. So it is asking, among the 4 set, please provide the first set initial value. So what is the value of initial value of x? It is 1. What is the initial value of x? It is 2. Enter. So this plot has been generated. X-axis 1 and y-axis 2 is the initial point. So have you seen, the starting point has been marked as star. So x11, x12, that is the starting point, marked with star. Next, it is asking, because I have given the command grid on hold on, so this graph will be there. Already the program is asking me to give the second set of initial value. So it was -1, it was -2. So let's see what is the graph. So -1, -2, another graph has been generated. So third set, initial value of x is 2, another set is -2. Again, third graph with a different color. Last set of data, -2 and 2. So you can see that we have, for 4 different values, we have plotted the phase plane plot. I hope it is very clear to you. So that was for the experiment 1.